Hello and welcome to this lecture about cloud security, where I discuss securing cloud deployments. The main reference for this lecture is what you see here on the screen. And the main topics that I want to discuss is four aspects of cloud deployments: the data security, the application security, infrastructure, the cloud infrastructure security, and the cloud operations security. Right? So to begin, I want to talk about few concepts or few definitions. Probably you are aware of many of them, but just for the sake of completeness, I'm going to review some of them already. So as you probably know, service and deployment models in the cloud include the service models. Cloud can be deployed as a software as a service, which mean that the customer will have all of the infrastructure presented to them, including the software itself, including the application itself. The only thing that they need to supply is probably configuration and data. In platform as a service, the service provider will provide everything up to the operating system and the databases sometimes, or the programming tools, everything. So the customer will supply the application itself, will develop the application and deploy the application. In infrastructure as a service, now the service provider responsibility is to provide everything up to the virtual machine. So the customer will provide the virtual machine, will provide the operating system on top of the virtual machine and provide everything. These are the three main models, and of course there are some hybrid, or sometimes the service provider, the cloud service provider, can provide multiple of these or combination of these. Deployment, the famous ones are the public cloud service providers, Amazon, Google, Azure, Microsoft Azure, and so forth. These are publicly available. Anybody can obtain these services. The private one will apply all the concepts of the cloud, but they will be restricted only to the organization, one organization, or a small set of organization. Community extends the private to a group of organizations. For example, it could be a cloud a deployment for all government agencies, right? So that's the community, or all banks, so that's community, right? So it will be limited to a small set of organizations. And of course, there's always a hybrid between, right? So if we're going to talk about cloud computing roles here, I already mentioned the cloud service provider, which is the entity that offers cloud services to customers. And then we have the customer, who is the user, a single person, or an organization that consumes the service, right? Then we have what's known as a cloud service partner. Usually this is an organization that is neither the customer nor the provider, but it collaborates with the service provider to extend or enhance the provider offering. What I mean by that is, let's say you want to connect to Google Cloud, but Google Cloud is not available around the city where your organization is located. But you may go to your local network service provider, and they may be partnering with Google. So you connect to the local service provider, and they will allow you to connect through their network to Google, right? So that is one type of service partner, where they are the ones who deliver the cloud service locally. Another term is cloud service broker, which is it may be a third-party organization that you can use to um, connect to multiple service providers. They provide extra services on top of the regular service by doing some integration, some management, customization. They do some of the work for you as a customer, and maybe they manage the services for in your behalf. So these are the four roles here. We're going to focus mostly on the top two, the customer and the provider, so you can pay attention to the acronym CSP and CSC. All right, so what is unique about cloud services? Right? So the idea behind um, cloud services is not new. It has been around for a long time. It wasn't called cloud services, or it was called, for example, co-location services, where a data center organization builds a data center, provides all the infrastructure except the servers and the equipment. So you go to a location where you have the network, you have the space, of course, you have the fire suppression system, you have the security systems, you have the air conditioning system, you have everything except the servers themselves, except the hardware themselves. The organization goes, rent space, and put their own hardware in there, their servers, their switches, firewalls, whatever they want, and inside a space, inside a rack or multiple racks. And that will be a form of what we called co-location service. So that saves the organization from creating their own databases and providing their own infrastructure. Probably they cannot afford to have a diesel generator backup for the power. They may not be able to provide space. So they can rent a rack in a co-location facility. All right, so that was maybe the original form of a cloud, because the infrastructure is somewhere outside the organization space. But the cloud actually took off with the help of virtualization. And what we know, or what we talk about when we talk about cloud today, where we mean certain characteristics. The first one is the on-demand self-service, right? So self-service here means that I can go to a website provided by the service provider and click on few buttons and create a virtual machine for me with all the characteristics, all the specifications that I want, right? And this will take effect almost immediately, and I will be able to provision whatever resources using the interface that was provided to me. And I can do the same thing by disabling or deprovisioning the service anytime I want. And that will happen without making a phone call or talking to anybody. It can be done without human intervention, right? So that's one aspect. The other aspect is broad network access. So these cloud services, to be able to use them, we have to have a network, and we have to access them. We can access them through multiple forms like tablets, laptops, workstations, mobile phones. They are always available through multiple ways. Another aspect of the cloud is the multi-tenancy. This is from the cloud service provider perspective rather than the customer perspective. The service provider will build the infrastructure that allows multiple users to share the resources, share the same infrastructure. Which means that From the service provider perspective, they have to have a mechanism to separate these resources, ensure that they are not overlapping in some sort, and we'll see later that that has an impact on the security. Another aspect of cloud is what's called elasticity and scalability, right? The ability to expand the infrastructure and shrink it as we need, right? So one of the appeal of the cloud service provider versus what I mentioned before as co-location is that with the co-location services, okay, you provision 10, 15, 20 servers. If your business grows and you want 40, this means that you have to go and buy another 20 servers and go install them. And that will take time and effort and resources, and it's not going to be instantaneous. With the appeal of the cloud is I can double my resources almost instantaneously, in few minutes or few hours at most. So I can scale up and scale down the resources as the business grows or shrinks, sometimes over days, not even months. Sometimes, all right, I know that I have a business during Monday to Friday, and the business slows down during the weekend, so I can scale up and down the infrastructure based on that. So that's from the customer perspective. Again, from the cloud service provider perspective, there is a resource pooling involved. So what makes the cloud useful or efficient from the provider perspective is that multiple users, each one of them wants 1 terabyte hard drive. I don't necessarily need to provide X multiplied by 1 terabyte of hard drive to each one of them. I know that they probably will share these, each one of them will have um, a smaller need, right? So I can have, rather than, basically I can provide oversubscription, right? So one of the terms we can use is oversubscription, where I can um, have less resources that serves a large number of users. Same thing with everybody wants 5 CPU cores, but I may have only 50. So these five, if I give everybody five, I will be able to serve only 10 users, but I can actually serve more than 10 users by pooling resources. Assuming that not everybody is going to use those 5 cores at the same time, right? And finally, or maybe not finally, but one other aspect is the measured service. I need to measure the service so I can charge users per the use of the services, and this is appealing to both sides, both the customer and the service provider, because the service from the customer perspective, instead of having resources that are not being used and we are still paying for them, like infrastructure servers that are installed, provisions, powered, but they're not being used. So with the cloud computing, I can pay per use. If I don't use the resource, I don't pay for it, and vice versa. So these are the appealing characteristics of computing of the cloud model, and this is what makes customers prefer the cloud model over buying hardware. So what makes cloud possible, as I said before, virtualization. Without virtualization, we can build cloud, but it won't have all of these characteristics. We won't be able to do, for example, rapid elasticity or the on-demand self-service. So virtualization allows us to do all of this. So that's the major building block. We need networking because the cloud is somewhere else, so we need to connect to it. So networking is essential. Databases or storage is needed for one of the main building blocks for cloud. And when we talk about databases, we refer to structured data repositories, right? Databases come in different shapes and sizes, so we're going to talk about databases in general here. Orchestration. Another thing is when we want to provision resources using a website or using an interface, and we want to increase and decrease the resources that we have, we need to have tools. And these were called them orchestration tools, which allows us to do a lot of automation and coordinate multiple services together. And that allows us to execute a lot of complex workflows, right? So I want to provision multiple VMs, and I want to install certain application or certain tools on each VM, and I want to supply configuration. I want to prepare all of these virtual machines to be able to provide service to customers. This is not going to be done manually. If I am going to do it manually, it will require a lot of human resources, a lot of time, and could be subject to errors and all of that. So there are a lot of orchestration tools that allow us to do all of these automatically. So when it comes to security, because there is not a lot of overlap between what the customer can do and what the service provider can do, we have this concept of shared responsibility model. We're talking about shared security responsibility model, right? So the shared here between the customer and the cloud service provider, and it really depends on what kind of model we're talking about. So when we talk about infrastructure as a service, now we know that the customer will install everything from the operating system and up, right? So that means that the customer is the one who's responsible for the security of all of these pieces. If we're talking about platform as a service, where the service provider will provide up to the tools and then the customer will come and develop software. Okay, so in this case, the customer is responsible for everything that they do above the tools that provided, so that the application itself, application security, has to be the responsibility of the customer. Finally, for software as a service, we are using, let's say, any application that is provided. Outlook, for example, Microsoft Outlook is an example of software as a service, but we are responsible as a customer for securing access to this application and maybe securing the configuration, securing things that is part of our what we can do. So if you go and look at service providers, each one of them provides some kind of a map that illustrates what they are responsible for and what the customer is responsible for. So we have here an example of the AWS responsibility model, and you can see here now the naming depends on their services. So the first service here to the left is related to infrastructure as a service, and you can see here the orange color represents the responsibility of the service provider, and you can see here the hardware is their responsibility, and the compute, storage, database, and network is their responsibility. And then when you go up, you see that the responsibility of the customer is the data encryption, server-side encryption, network traffic protection, firewalls, configuration, and so on and so forth, right? And this is a container service where now you have to go and look up what that means exactly for the service from the service provider perspective. But you can see here that each model or each delivery model has a separation between what the customer is responsible for and what the service provider is responsible for. If this is another type of model from Google, shared responsibility model, and you can see here if you have on-premise infrastructure, the whole thing is the customer responsibility, right? So if you have a server that you are installing in your organization, and so you're responsible for securing the hardware, the boot, and the kernel, the storage, the network, and all of it. While if you have an infrastructure as a service, you are responsible for up to as a service provider will be responsible for everything. And then up to the audit logging here, and then from that point up, the guest operating system, the network security, the access and authentication, all of that is the responsibility of the customer. And you can see here there is network appears twice. So the network at the bottom here refers to the network in the cloud data center, right? So eventually the cloud is a data center somewhere. So the network of the data center, the security of that part is the responsibility of the service provider, while the virtual network that the customer creates to connect their virtual machines is their responsibility. And you can see here the platform as a service. The model indicates that the customer is responsible for everything from the web application up, while the rest is the service provider responsibility, including identity management for login and so on. So this hopefully clarifies the difference or the meaning of the shared responsibility model. And every service provider will give you a certain map like this and say, okay, this is your responsibility, this is our responsibility. Okay, so as I mentioned before, we are going to talk about 4 different aspects of cloud security. So we're going to talk about data security first. All right, so the data has a life cycle. The life cycle starts from the creation of the data and up to the destruction of the data eventually, right? And long story short, we need to secure the data in all of these in all of these phases of the life cycle. So let's go quickly over each one. The create, well, this is where the data is created or modified, and to at the creation time, we need to classify the data from the security perspective. So we need to make sure that the data is probably properly classified, whether it's at what level of security we want. Then the data is stored. Imagine application. I'm entering information about, let's say, a user. So that's created, and I need to store the user information in a database. So this is the storage part. The data is going to be used over time by other pieces of or other parts of the application. So that's the use or the consumption of the data. And then the data could be also shared among different applications. So if you have a database that has user information and then you are sharing it among multiple applications, so that's the share. Archiving, maybe the data over time you want to save it for long storage and it's not active anymore, but you want to save it for maybe statistical reasons, or maybe for as a backup. Maybe you need it later, so you need to archive it, and eventually you need to destroy it. You need to get rid of it, right? So all of this needs to be secured. Okay, so one aspect of the cloud services is that um, the the infrastructure itself can be spread over a wide area, right? Physically, it could be you if you are creating or if you are provisioning cloud services, you may provision the cloud services over a wide range of physical locations. You could be doing this on purpose to have redundancy. Some of the benefits of cloud services is that I don't have to put all of my infrastructure in one location. I may choose a cloud service where I can put some of my virtual machines in data center in Toronto, while another virtual machines in data center in Montreal, and maybe some other places in Europe. So I can spread the infrastructure over a wide range of location. And this could be also done by the service provider without my knowledge, right? Um, you're using microservices, for example, and or using a database. You don't really know where the database physically is stored. So of course, that causes some kind of a challenge from the security point of view. So we'll call this data dispersion, which means that the data can be broken, not just the infrastructure, but the data itself can be broken into smaller chunks and can be stored across different physical storage devices. Sometimes these storage devices can be in different data centers, different physical geographic locations altogether. All right, so um, what's the benefit of that? It could be the benefit is that redundancies and data protection. So I'm spreading the data over a big range and creating redundancies. So if I lose part of the data can be reconstructed uh, by the remaining parts. All right, so that's the benefit. And it could be done, as I said, behind the scenes. The customer is not aware of this. It's done by the service provider themselves. But that creates an issue from the security point of view. One issue is that the data is spread over a wide range of locations, and each one of these segments, each one of these pieces needs to be secure by certain mechanisms. The other issue of this is legal. Now, jurisdictions, every country has their own laws that control how the data of the users is being handled. Um, so you could be, as a customer, responsible for making sure that you are not violating local laws. If the local laws that says user data cannot be located outside of the country, then you have to make sure that any service provider will not take your data and put it somewhere else where it violates these rules. So that creates a little bit of complexities when you talk about regulations, and also creates complexities from the from the security perspective, of course, because now the data is spread. It's not located in one location, but it's spread over a wide range of locations. Okay, so let's talk about storage types. You cannot secure something without knowing what it is. So let's talk about storage types. The first storage type is ephemeral, which means temporary. So this is like a RAM where you um, create the data. It's located in the RAM, and then by the time you turn off your virtual machine or turn off the container, the memory is gone, so the data is lost. Raw data, this is our raw storage, is where you can put. It's like it actually includes a lot of things. They're all under the umbrella of logical unit number, and this includes maybe a hardware, hard drive, or SSD, or part of it, right? So that's could be something that you. It's like a hard drive connected to your virtual machine. Um, Hard drive or the raw storage, one of the characteristic of your hard drive is you can read and write from it anytime you want, and it provides relatively fast access. But it could also be expensive in terms of performance. So another form of storage that service providers uh, provide is a long-term storage. If you know that you want to save data, but you don't want to access it immediately all the time, you want to just bring it up every once in a while. So they provide something called long-term, and this could be used for archiving. You don't expect that you can access it immediately anytime you want. You probably request the access, and the access will be available within hours, maybe instead of within seconds. Um, Sometimes raw and volume are sort of similar. So the volume is like a folder, and you may be able to access that folder or that volume like you access a virtual drive in your VM. And sometimes another type of storage is called object, which allows you to store um, a file or a database or an image, and you access that not the same way you access it in a hard drive, but you access it as an object. And this is another form of where you don't really know where the object physically stored, but you can store it and you can retrieve it anytime you want. Um, but the access mechanism is using object access mechanism. You can have also virtual desks attached to let me go back one step and refer all of this are provided for infrastructure as a service model, right? So you see slightly different terminology when we go to the platform as a service. So platform as a service, remember, you don't create your operating system yourself. You are provided with the tools. So you may, among these tools could be a disk where you can store information like configuration parameters, for example. You can access databases as part of the tools that you have. You can also access binary large objects or blob that you can use to save images or text files. This will be something similar to the object here in the IaaS. All right, so these are the three types commonly used for platform as a service. And then you go to software as a service. In this case, users will probably supply configuration and some user identities and all of that. So the storage is almost completely hidden. The user don't have much control over it, but you can still you can still manipulate some data via web GUI. You are storing a file, for example, for the online Microsoft Word, right? So you can have file storage, content file storage. You can also have something called content delivery network, where the content itself is spread over wide area or geographic area, and you can still um, access this. The example that comes to mind right now is something like OneDrive, Microsoft OneDrive, where you can still store some files. You still can access them from multiple locations. Um, you have certain limitations. So if you go to OneDrive, for example, and you look at what you can save, it's not like everything you can save there. There are some limitations on what you can do. In terms of not just in terms of size, but also in terms of what kind of information you can store. Okay, so these are the types of storage that you need to be aware of, and they are different depending on what kind of a model that you use. What are the threats? We're discussing this, so we know what the threats are. The main threat is, and the most common, is unauthorized access. And unauthorized access threatens confidentiality and sometimes the integrity. So, confidentiality means people will access information that they're not supposed to access, but sometimes also they may modify this information, which that's what we mean by threatens the integrity. So somebody goes and modifies certain data in a database. Well, now we don't have the original database anymore. The threat comes from either external or internal sources. The external sources are obvious, but the internal sources could be internal sources from the customer side or from the service provider side. What makes this even harder to control is the geographic diversity and what we talked about, dispersion, because now we have data all over the place, and the more widespread the data, the harder controlling access to it. We also have another threat, which is the unauthorized provisioning. So this means provisioning means creating the data. And one of the common things that you can hear sometimes is the shadow IT. What is shadow IT? Let's say the organization has certain applications that the employee can use, has certain um, locations where you can store information, and usually the organization will put, if they're doing their job right, they'll put security mechanisms that control access to these resources to prevent any security threats or mitigate security threats. What users or employees can do sometimes is to circumvent all of these security mechanisms by creating their own uh, resources, and this is what's called shadow IT. All right, so for example, everybody may have Windows comes with OneDrive or any other cloud storage, right? So there are other examples as well. So rather than storing the information using the company's storage facilities, I'll store the information in my own personal locations. The same thing goes for using applications that are not sanctioned by the organization. So I like Excel, but the company does not provide Excel, provides another piece of software. But I like Excel, so I go and use Excel online or the Google equivalent to Google Spreadsheet or something like that. So that's what we mean by shadow IT, and that creates or makes creates information and data where it's not located where it's supposed to be, right? And the third threat is denial of service attack, where it threatens the availability of the data. Denial of service attacks, as you know, could target connectivity or could target the servers themselves and prevent them from supplying the information to users. So make them inaccessible, basically. Data corruption or destruction. Again, somebody may go and change the information, even if it's encrypted. Encrypted data is not necessarily immune to corruption, because somebody may just take pieces of the encrypted information and scramble them or replace them with something else, and that renders the whole thing unusable, right? So that could be done also by targeting the hardware, and that would lead to either corrupting of the data or deleting it altogether, right? Somebody may delete the information. Theft or physical media loss. Now, this probably for a cloud, it's not under customer control, but under the service provider control. The employees of the service provider, or the service provider has the media, and they could be subject to somebody going and stealing the actual hard drives or the actual physical media. The service provider and or the customer may be subject to malware and ransom. The customer create a virtual machine. The virtual machine could be attacked by a virus, and that will corrupt the data or cause other problems that we discussed earlier. Another threat is the regulatory non-compliance. As I mentioned before, there are a lot of regulations about handling information, especially personal information or medical information, health information, and so on. So you could, as a customer, be violating one of these regulations if you don't follow the rules by locating the information somewhere else, or not securing it properly, or any other act that violates the rules. And finally, the other threat is the jurisdictional issues. And this means that maybe you are moving data to some other countries where you're not allowed to move them, or maybe because of the cloud coverage across multiple countries, across multiple continents. Either the customer service provider or either the customer or the service provider may be violating these rules by moving data across boundaries. Okay, another aspect or another threat is the improper disposal of either the data or the physical hardware that controls the data. Now, I mentioned before that we have to secure the data in all phases of its life cycle. So destruction is supposed to erase the data completely, but if the data is actually stored in the cloud, I don't really have access to the hardware itself. I cannot just go and break it with a hammer or do other things that completely get rid of the data. So I may click delete, but what is really delete? So we need to make sure that the data is actually destroyed. So we need to make sure we will see how we can do that later on, but we cannot just rely on just a simple function of delete to ensure proper getting rid of the data or destroying the data. And if you are a service provider, then you have to take take the proper measures of destruction, the physical media, that you own the physical media, so you have to make the proper, or you take the proper steps to destroy the media when that media is no longer useful, is no, maybe the hardware passed its lifetime and you want to destroy it, so you have to take proper step to destroy that physical media. Okay, so let's see how we secure the data. So we have multiple security strategies. The first one is encryption. Encryption prevents unauthorized access, prevents um, I'm losing the words here. Prevents eavesdropping. So encryption is the main mechanism to secure media against unauthorized access. Encryption requires keys and requires cryptography algorithms. So the idea here is usually when we talk about cryptography, we uh, use the Kirchhoff's principle, which means that everything can be known. All the algorithms can be known, all the techniques of cryptography can be known, with the exception of the keys. So we cannot make an assumption that, oh, we have a hidden algorithm, nobody knows about it. So we have to work on the principle that everything is known with the exception of keys. So the main thing that we need to save here, or need to handle very carefully, is the encryption key and the decryption keys. So we need to manage the keys. The keys here, because we are using many keys, if you have your own hardware and your own data center, you may have few keys that you can use to encrypt the data. But when you're using the cloud, you may be dealing with tens of keys. So you need certain mechanisms to handle the keys. We're not going to talk about the actual techniques here, but we just want to highlight that managing the keys becomes a major issue in the cloud. So that includes the creation of the keys, storing the keys, sharing, archiving, and same thing as any other data. It goes through a life cycle as well. We have something called FIPS, or FIPS 140-3. This is a standard used by the US and Canada to certify the cryptography hardware. The encryption itself, because it's a computing intensive technique, so we usually rely on hardware to do encryption quickly rather than doing it by software, and also more secure this way, right? So how do we know that the hardware itself is not subject to attack? The cryptography hardware not subject to attack. So there is a standard, and this standard is used to provide certification for the hardware. We can say, well, this hardware is actually certified to do cryptography in a secure way. Okay, so when we talk about encryption in the cloud, we can think about encryption in several levels. So let me just show it in a diagram quickly. So if you have, let's say, hard drive, and the hard drive includes a database. So this is the hard drive. This is database. And the database will include tables, and within the tables we'll have records. So you can encrypt record by record. So each record will have its own, will be encrypted. And now your application can go to that record, and every time you want to access the record, you can decrypt it, access it, modify it, encrypt it again, put it back in the database. You can also encrypt the whole database, so inside the records themselves are not individually encrypted, but you can encrypt the database as a whole. And every time the application needs to access the database, you decrypt the database, you access it, you modify it, and then once you're done, you encrypt it and store it. So that's another level. So the record level or the database level, or you can encrypt the entire hard drive or entire storage in this case. So you encrypt the hard drive when you don't want to use it, and then when the application needs to use it, you decrypt it and you access the information. Right? So you can have each one of these levels in the cloud. It depends, of course. You cannot. It depends on the application, right? So, for example, you want to save an image, and you don't want to access that image all the time. So you may, before you send it to the object level storage, you just encrypt it and put it there, and then when you try to access it, you decrypt it. So each one of them, storage level encryption protects data as it's written to storage, often controlled by the cloud service provider. So this could be every time you want to create a transaction, you save something, that encryption, decryption of the hardware is done, or the storage is done by the cloud service provider. Volume level, again, volume, think about it as a folder. It can be controlled by the customer. Object, also usually controlled by the customer. And file level. So you will see here multiple levels. And if you go back to the storage types that we talked about, you see all of these. So that's encryption is one of the main techniques for securing the data. Another technique is hashing. So what is hashing? From cryptography, we know that hash or hashing is taking any amount of data and using a hashing function to transfer it into a fixed size information. This could be 128, could be 256 bits, could be 512, any size, right? We know that hashing is one-way function, so if you do hash, you cannot go back and retrieve the original information. So that's not unlike encryption, where you can encrypt, decrypt the information. It's a one-way function. We also know that any change in the original information, any change will result in a completely different hash. So if I want to change something inside the file and then hash the file again, it will result in a completely different hash, which is not the same as the original one. So hashing is a good technique for integrity check, right? If I hash any file that I want to protect against any modification, I hash the file, I'll save the hash in a secure location, and every time I want to access that file, I probably will hash it again and compare the two hashes. If they are the same, then I know that the file has not been changed. If they are not the same, I know that the file has been modified. All right. Hash also, before I, just a reminder, we have the issue of collision in hash. What is collision? The collision means that there are actually two different files, completely different files, but they, when we hash them, they translate into the same hash. And this is theoretically possible, and we explain this by the birthday problem or the birthday paradox. It is possible because the size of the hash is limited, so it is possible that any two files, totally different information, databases, whatever, images, whatever, they can be translated into the same hash. So by increasing the size of the hash, we reduce the probability that two files will have the same hash. So hashing is good, and it's basis for digital signatures as well, to make sure that um, when we sign the hash with the private key in public key cryptography, we make sure that we know who created the hash, right? And this is, or who created the original file, which is the basis of the digital signature concept. So hashing is always good to verify that the information has not been changed. And as I mentioned, we want collision-resistant hash, means a hash technique that reduces the possibility of two pieces of information result in the same hash. Another technique is masking. So masking, you see it sometimes in everyday life when you receive bill and you see that the credit card information does not appear all the numbers, but you see only the last few digits of the number, and this is masking. This is an example of masking, where the actual data, when represented in the application or in a report, printed report, it does the application hides part of the data, so whatever left is not really cannot be used to identify the person, or cannot be used to extract the information. Okay, so common example, social insurance number. It has, I don't know, 9 digits or 12 digits, whatever. And if you see the document, printed document, or if an employee looks at, let's say, an employee who's handling HR information, see a report and the SIN number, instead of seeing the whole SIN number, they see only part of it. So in this case, what we call this masking, and this hides the information. We can use this to mask part of the sensitive information, so we don't want to give we don't want to give away the phone number of the user, or we don't want to give away the SIN number, or any student ID, for example, any sensitive information. So we can mask it. We can also do tokenization. Tokenization replaces the sensitive data with tokens, right? So instead of having the actual information, we represent it with the placeholders, or something that we use it later to extract the information itself. But if we want to, but in most cases we just want to we will use the token as a replacement of the actual data. So for example, here the original credit card number is this, and instead of using this in the reports or using this in databases, we're gonna replace this with a token. And that will allow the application to handle any transactions with the user, right? So we know that the user has a credit card information. We handle the transactions and everything, but the actual number is not stored in the database as is. It's stored as a token. And only when we want to charge the customer we will go and to maybe more secure database where we extract the actual credit card information and use it. So employee, for example, who wants to handle the packaging of the customer order may not need to look at the actual credit card number. So the credit card number will be saved away. Another security strategy is data obfuscation, if I pronounce this correctly. That means removing or replacing sensitive data elements by either substitution, shuffling, value variance, deletion, or nullification. So, and also by encryption. Encryption usually means that we are replacing the actual data with something that looks random, right? So it's also a good technique. So, and this technique will destroy the actual application, destroy the actual data. So we will use it only if we want to keep some of the data, but we don't want maybe the whole thing. I'll give you examples as we go along. So, for example, shuffling will take the actual data and shuffle them around. So original data says customer A bought electronics, customer B bought clothing. We can shuffle the data by saying customer A bought clothing and customer B bought electronics. So that will, what is the benefit of that? The benefit of that is that if somebody try to extract some information about customer A, they won't get real information because we scrambled the data. So now customer A is always buying certain medication. So if anybody looks at their history, say, okay, they have this disease because they are buying the same medication over and over. But if you are shuffling this data and scrambling it over many customers, this information is lost. So if I look at the customer A history, I won't be able to tell what are the patterns of this customer. So that's good. But it also destroys the information. So if I want to go back to the customer and see what they bought, I won't be able to see it anymore. So why this is good or why this is useful? Let's say I'm as a organization, I am only interested in the revenue. I am only interested in calculating revenue data, how much purchases happened for this product or for that product, and I don't really care about who bought it. So scrambling this information will still save the actual revenue information. It's just now that it's not associated with a certain customer. So shuffling is one technique. As I said, substitution, replacing sensitive data elements with alternative values. So instead of actual names, we'll use pseudonyms or some kind of identifiers. So if I have a database of students and their grades, I can replace that with random names. Or I can replace that with student A, student B, student C. So now the original information is lost. I cannot go back to the actual student's name, but there is still value. If I want to do statistics, it's still, the grades are still there. I can extract statistical information from that. I can also do a value variance, which takes the information and randomize it a little bit, adding or subtracting random numbers, so the actual information uh, is destroyed, is lost. But um, um, maybe I still have some other use of this. I can delete some of the information altogether if I don't need it. I can nullify it, replacing sensitive data with null values in a database. So all of these techniques uh, saves the data or um, protects the data. And each one of them is good for certain applications, are not good for others, right? Um, Another security strategy to protect the data is de-identification. So de-identification removes personal identifiable information, or PII, and any indirect identifiers from data. Um, so I could, for example, say patient name is Jean Smith, medical record is 123456, and instead of that, I will remove that and replace it with something totally different, right? Random number instead of the actual information record. So now I protected this and also changed the name of the patient. Um, so now I destroyed the original data, but this data is still valuable in case I want to do some research. Um, okay, so John Smith, who has a medical record, may have certain uh, history, and this is still recorded, but any relationship between the actual patient and their medical record is destroyed. So I still have the medical record. I can use it to do research, I can use it to extract information, but the actual names of the patient is removed. Another strategy is the data loss prevention. So data loss prevention means that we want to protect the data against leaking, unauthorized leaking, um, or unauthorized analysis as well. So to do that, we need to discover any methods for data leaking or data loss, and I want to monitor it and enforce the data loss prevention. Uh, the general technique for data loss prevention, if I have my own network and I have control over my infrastructure, the general way to do it is to have something like an IDS or IPS, where the IDS look for credit card information in the packets passing through it, and once this information is detected, it can be blocked, for example, or the administrator is alerted. If I want to do this in the cloud, it is a little bit challenging, more challenging actually. Why? Because the cloud environment does not have single entry, and also I don't control the infrastructure in the cloud. So now monitoring traffic to detect whether there is a data leak or not becomes a little bit more challenging. Okay, so how do I identify uh, data loss, or how do I identify sensitive information? So I can use scanners to locate to locate the information itself. So I may scan the storage to find what are the files that may contain sensitive information, and that includes all the different type of storage that I have in the cloud. I may scan the files and that applies to network as well. I may scan the files for any patterns, known patterns. Social security or social insurance numbers have certain patterns, so I can look for this patterns. Phone numbers have certain patterns, so I can look for that. Um, Student IDs have certain patterns, so I can look for that as well, right? Looking for patterns and scanning patterns it requires highly privileged credentials. So the software that does this or the tools that do this, they have to have really high privileged credentials to be able to do the scanning, because now imagine you are scanning every storage device, every file, every database to look for this information. So this is one of the most sensitive tasks that security can do, and also it needs the highest protection. Monitoring, I said before that if the data is in motion, so the data is traveling across the network in a packet, you can use network-based monitoring like IDS, for example, to monitor any data leaks. If the data at rest or storage, so it's not being transferred anymore, means that you have to use different tools. The IDS will not be able to detect data leaks in a storage device or in a stored file. So you have to use different techniques. So that will probably require some other tools to do that. The enforcement, is the last part of the data loss prevention, which includes how to actually prevent the data loss. You can block the users, or you can block packets, drop packets in case of IDS or email servers. So that's different techniques for data loss. Again, these are the general techniques, and the assumption here is that we talked about some of these techniques in previous lectures, so I may not go over the tools and techniques here in detail, but the idea is to be aware of these when you are deploying cloud as a customer, or if you are the one who's responsible for designing and operating the cloud infrastructure itself. So you could be, as a network engineer, part of either the customer or the service provider. I mentioned before that data loss prevention has challenges in the cloud. So the challenge, especially when you are not controlling the infrastructure itself, which is in the software as a service or platform as a service, you don't really know where the data is. So it's a lot challenging. So you need to rely on the cloud native tools in this case. Hopefully, when you deploy these services, you have to choose the cloud service provider who provides stronger data loss prevention, and you may need to rely on their own tools rather than deploy your own. And you need to make sure that these tools are compatible with the operating systems that you are using, cloud environments that you're using. Data loss prevention, whether it's at rest or in motion, it will add an extra delay, because it's extra processing, right? So if you are passing everything through, let's say, an IDS, the fact that the IDS has to process these packets means that there is a delay in the processing and delay in the lower performance. If you are doing scanning in the file storage, all of that, this also means there is certain performance overhead that you are spending on this process. All right, moving away from protecting the data, and now we're going to talk about protecting the infrastructure itself, the cloud infrastructure. And again, you can look at it from the customer point of view and also from the operator, from the provider point of view. So the physical environment of the cloud is just a regular data center with servers, networks, routers, storage, etc., etc. So all of this is no different than any physical infrastructure. So, and that includes the server rooms, data center, physical locations, buildings, etc. So if you are the customer, well, that's beyond your control. You don't control the physical infrastructure, you're just using it. So the responsibility will be mostly or completely within the service, the cloud service provider themselves. We can talk about physical security. This means that you have locks, you have guards, you have fences, you have security cameras. All of these are part of the actual physical security that the service provider will implement. You may notice that any data center probably doesn't have any windows, right? Or very, very, very few entries. It's usually blocks of concrete that you don't see anything, and that's part of the security mechanisms. The identity and access management, or the IAM, which we talked about in previous lecture, plays a central role in implementing and controlling access, whether it's access to physical servers or whether access to any of the applications, anything like that. In this context, we're talking about physical environments, so we need to have tokens, we need to have access cards, we need to have all of these techniques that we talked about to provide access to the physical locations. If we need any access remotely, for example, we need to make sure that it's going through VPNs and implements encryption, digital certificates for authentication, and so on. Right. So these techniques, we talked about them before, but now we need to implement them to protect the physical environment. Aside from the locations, we're talking about servers and data and storage and all of that. So that's include the physical environment. Part of the physical environment also, or part of the infrastructure, is the network and communication. So there is no data center, and specifically no cloud data center without network. So everything we talked about in securing network and communication applies here. Everything, firewalls, VPNs, IDS, IPS, all of these apply here. If you go back to the slides, we see that we have two types of network. The network that I go quickly here to the model. We see network that part of the data center network, right? So it's the behind the scenes that the user doesn't see it. And also we have a network that the customer creates, typically virtual network that connects the infrastructure that the customer creates. So the network, when we talk about network, it's a shared responsibility between the two, between the service provider and the customer. Each one of them will have a part in protecting the networks. In terms of access, you're going to access the network from the organization to the service provider. So you can do that using a VPN. You can do that using HTTPS. You can do that actually with a physical connection as well, fiber optics. So that part needs to be secure. And the security of that part, the connection to the service provider, will be the responsibility of both parties as well. So not just the network in the data center, but the network between the organization to the data center, to the cloud. So that includes all of the things the systems that we talked about, including firewalls and other systems. So that will be part of it. You can also, when we talk about the virtual networks that the customer creates, these needs to be protected as well by different mechanisms. So you can think of the network that the customer creates as any other networks where you can put firewalls, you can put IDS, you can put all these security mechanisms. The cloud service providers, sometimes they put tools, or they provide tools. So a virtual firewall may be provided by the provider. You don't have to install your own firewall, but you can use the mechanisms that the cloud service providers use. But you have to make sure that these are adequate tools. Another aspect of the infrastructure is the compute. The cloud is the compute, right? Of all these. We talked about the storage before, but the compute part is the CPU, or the resources that you are going to use. So the actual CPUs, the actual servers, the hardware is securing these is the service provider responsibility. So they are securing the physical components, and if they are platform or service or software service providers, they need to go above, and they need to control, secure the operating system and the platform and the tools as well. The customer will be responsible for securing the environment that they control. So if you are creating virtual machines, you need to secure the virtual machines. If you are creating an application, you need to secure the application. How you need to secure who access these applications or these virtual machines. So you need to put the company's policies there. If you go back to that shared model, if you remember it, in the infrastructure as a service is the customer has the most security responsibility, right? You put an operating system, you are responsible for securing the operating system, right? Securing the software patching, eliminating any vulnerability in the operating system. So the whole thing is your responsibility, right? And as you go up for the platform or the software, the security responsibility of the customer will be only the part that they control. We talked about virtualization, so this slide is just a reminder of what kind of virtualization we talked about. And the most common type of virtualization is what we call the bare metal. The bare metal, where you have the hardware and you install the hypervisor. The hypervisor is the piece of software that allows virtualization. So you install the hypervisor directly. VMware is one example of the bare metal. So we can install it on the bare metal, and then VMs, virtual machines created by customers, will be installed on top of that. Right? So securing the hypervisor will be the responsibility of the service provider, and VMs will be the responsibility of the customers. Another type of type 2 where you have the bare metal, you have the operating system like Linux, and then you have a hypervisor on top of that. Windows, if you are running a VirtualBox on top of Windows, that's an example of type 2. As I said, the most probably common type of in-cloud service providers type 1, and then the customers will put their virtual machines. So in any case, access to the bare metal, access to the hypervisor, and configuring the hypervisor, all of this will be the responsibility of the service provider, and proper identity management systems need to be in use. We talked about storage before from the customer point of view. From the service provider point of view, the storage is part of the infrastructure, and that will include all the hard drives, SSDs, anything that's used as storage. And I talked before about the responsibility of destroying this at the end, right? So a storage, storage is used by the cloud service provider, so they are responsible for maintaining the physical protection and also anything that needs to be like replacing it if it fails and so on. So that's the responsibility of the cloud. But at the end, you need to destroy it. A hard drive will pass its lifetime. We start getting errors, we start getting failures. So we need to take it out. But even damaged hard drives data can be retrieved from them using more sophisticated tools. So they need to be really destroyed. So how do we destroy this? One of the techniques is to go, and this can be done by the customer or the service provider if you don't trust the service provider. So what do you do to make sure that your data is being completely destroyed? So you can go and encrypt it. So you go encrypt the files that are sensitive, or encrypt the entire hard drive if you are the service provider. So you encrypt, you lose the key, destroy the key, and then you go and delete the hard drive or the files. So what happens next? Even if somebody is trying to retrieve the data, what they will retrieve is the actual encrypted data. So they're not going to be able to look at it. Because what they're going to get encrypted information anyways. Okay, finally, when we're still talking about infrastructure, right? So one of the things that we need to talk about is the management plane. So when we talk about management plane, these are all the operations, protocols, tools, etc. that are used to manage the infrastructure. So the management plane controls cloud environment, configuration, and access. We need multi-factor authentication. We talked about different access control mechanisms, so these apply again. So you can do role-based access control where employees have access based on their job description, based on their roles in the organization. You could also go deeper and more granular by using attribute-based access control, where, as we talked about before, they are the most granular and most details. So you can say you have to be an IT manager who works in this specific location, and you can do this only during 8 a.m. to 4 p.m. time, right? While you are physically in this room. So you can be very, very specific here. Any administrative accounts must be protected, and that's general advice, right? So it can apply whether you are the customer or whether you are the service provider. Another best practice is to separate the accounts. If you are a customer and you have multiple teams, some of them they do develop applications, some of them they do testing, some of them they manage the production environment. You don't you create separate accounts so the people who do the development they cannot access the production and so on. So you separate, and this will go also for the service provider. You can look at it from both sides. You need to separate the management functions from other workforce functions. That applies to anything, right? So if you are managing managing the routers means maybe changing the routing protocol or changing parameters in the routing. So that is different from people who monitor the performance of the router. So you separate them. You separate the tasks. You separate the functions. People who monitor the performance of the router may not necessarily be the same people who go and try to change the configuration. Right. So that's really necessary, and it's a general best practice for security, not just for the cloud. Any organization need to do all of this based on risk assessments. So when we talked about risk assessments, the idea is to know what the vulnerabilities are and then try to mitigate them. So again, that applies to both customer and service providers. So you need to, the idea here is to follow security practices, maybe use something like SOC type 2. Remember, SOC type 2 applies to cloud service providers. So the cloud service providers to give assurance to customers that they are following best practices in security, they can apply SOC 2. So SOC 2 organization comes and write a report that says these guys are actually following the security recommendations. You can also use the ISO 27001 and particularly 27018. If you go back, you'll see what these are. And also there are other standards that the cloud service providers can rely on. Generally speaking, we need to apply rigorous authentication methods, including identity and access management systems. You see here that the IAM appears in multiple slides because really when you have the cloud, you have your infrastructure somewhere away, access to that infrastructure becomes or controlling access to that infrastructure becomes really important, whether it's from the customer perspective. The customer here is the organization that uses the cloud. But remember also, if I am the organization and I am selling stuff, right, and I have my infrastructure is at the cloud, there is also somebody else who are the users or the my customers. I am the customer of the cloud service provider, but also I have my customers who are buying stuff from me. So those also needs to be make sure that they are using the proper authentication methods. So that applies to everybody involved in the cloud. Cloud vulnerabilities. Okay, so the cloud, by its nature, has certain vulnerabilities, certain threats, certain attacks that may look similar to the in-premise, or it could be something different, right? The first thing that makes the cloud unique is that it's internet-based. Everything is internet-based, which means that it's exposed to the internet. I cannot say, well, my infrastructure is within the boundaries of my organization. Nobody can access it. I cannot do that. It's the primary access to the cloud is the internet, especially from the customer, from the ultimate user's point of view. Um, in I mean, it is possible. Let me explain this in a diagram. Uh, let's say I am I am organization here, right? And I'm using the cloud. So I may have a physical connection between the organization and the cloud. Here is a router, here is a router, and there is a physical fiber connection between the two, right? So this may be secure connection. The organization has access to the cloud infrastructure here, and nothing is connected. But this usually hardly the case, right? So one of the reasons for implementing the cloud is that maybe a user somewhere located here, who is an employee, remote employee, may wants to access the cloud. I may provide access indirectly, or I may provide access directly. Another type of access, maybe I'm selling products and I have a user here, a customer who wants to access the cloud infrastructure. So the internet is a primary way. Maybe it's not the only way, but it's the primary way to access the cloud. So that explains the first part here, which is it has an internet-based nature, which means that it's susceptible to attacks from anywhere. Right? The threats may come from the attackers who not necessarily targeting the organization, but targeting the cloud in general. Somebody is trying to target Amazon, not necessarily the particular organization that use Amazon as a cloud provider, but Amazon itself. The attacks may come from other tenants, right? So what that means, okay, so I am a hacker. I will go to the IWS and buy a service and now try to attack other customers, other tenants. Right? It is a possibility. And sometimes comes from the actual physical geographic location of the data center. So the attack comes to a particular data center. The risks, I mean, it's not always malicious. Sometimes, all right, so if I know that my infrastructure, my virtual machines, my storage is actually being pooled with other tenants, we're using the same hard drive, physical hard drive. Just now I have a portion of it and the other guy has another portion. We're sending traffic across the same network. Do I know for sure that we are isolated? So I have to rely on the service provider to protect me. And there could be data leak due to that. If they're not following if they are not following best practices. Another risk, of course, can come from the actual service provider employees who may take advantage of their privileges and try to leak data from customers. So that's why encryption and key management is important and can mitigate a lot of these risks. Now everything is based on virtualization, as I said before. So virtualization has its own risks. Hypervisor security is crucial. Compromising the hypervisor will allow anybody to compromise all the virtual machines on top of it. Another risk is, one of the problems with cloud is that makes provisioning of virtual machines cheap. So custom people, users, tend to create virtual machines and forget about them, right? Because it's easy and it's cheap, it doesn't cost much. So you create a virtual machine, you use it for a while, and you keep it running and you forget about it. Those virtual machines can be another entry point for an attacker, and they can be used because nobody's monitoring them, nobody's using them. They can be hotbed for viruses, for attacks from hackers. They can be used to launch attacks on other virtual machines. Also, any sensitive information in the virtual machines that's kept there, maybe passwords for applications that's stored within the virtual machine, can be sensitive and can be used improperly. So that you need to monitor the machines. Okay, so now we know the risks. What are the mitigation strategies? Everything has to be designed with security in mind from the beginning, and that again applies to both sides, customers and cloud providers. So if you are responsible for designing the actual infrastructure, then you have to make sure that it's segmented properly, firewalls in place. There is isolation there between different functions and so on. Okay. If you are a customer and you are using the service provider, again, you have the responsibility in the infrastructure as a service to design your infrastructure properly. Encryption should be enabled for data whenever they are being in transit or if they are stored. You can limit the egress points within the data set, within the virtual network, virtual environment. And these are the locations where users of the infrastructure can get in and use the infrastructure. So you need to limit them. One way to limit them that comes to mind right now is that, okay, so I can access the virtual machines using HTTPS. All right, so HTTP should be blocked. HTTPS also would from certain ports. So you have to limit any entry points, any locations as well, any IP addresses. So instead of providing infrastructure through multiple entry points, maybe I can control it into few instead. If the cloud service provider has tools for configuration management, monitoring, and tracking, we should use them, assuming that they are designed properly and they can be trusted. And accountability, one of the four aspects of access control is accountability, right? And that is coming through using or reviewing logs, auditing logs, maybe using SIM to track the logs and correlate the logs and figure out if there is anything suspicious going on. All right, so design and plan security controls. So physical environmental protection. Physical assets include servers, networking gear, racks, facilities, etc. Protection involves defense and layers, access controls, and monitoring. Physical security in general rely on security zones. And security zones that we talked about earlier comes to play here when we talk about nested security zones. So the physical environment is located in a data center located in a building. The building may include multiple people doing multiple functions. Access to the entire building complex could be one security zone. Inside that security zone could be people who are actually responsible for managing the data center. And then within that, there is another, maybe could be another nested zone where only selected staff are allowed to go into the actual servers and maybe change them for maintenance or for other purposes, upgrade, for example. So you can implement the concept of physical zoning to protect the physical environment. And we also can protect the environment, the communication systems using segmentation that we talked about in other lectures. So one thing here, when you look at the system and communication protection, there is a line that says clear delineation of responsibilities in contracts and SLAs is crucial. As a customer and as a service provider, each one of them should know exactly what their responsibilities are, right? And this could be written in a contract and written in service level agreements. That should be done so that eliminate any potential gaps. No place for assumptions. If you are a customer, you shouldn't make an assumption that, oh, this is the responsibility, the security of this part is the responsibility of the cloud service provider, and I don't have to worry about it. Well, while there are shared model as we saw in previous slides, but this has to be written in contracts. So it's clear separation of responsibilities here and clear understanding of who is responsible for what. And we talked about data protection before, so that's a repeat here. The trust zones in the virtualization system protection comes into play here. The last point, trust zones establish security boundaries. When we talked about firewalls and zones, we talked about trust zones and how we can separate the network into different areas, public access, public zone, public access zone, operation zone, restricted zone, and a bunch of other zones as well, more restrictive. So again, back to when I designed the data center, the cloud, I need to make sure that I implement these concepts. You can see here that in this lecture we are repeating a lot of concepts that we studied before, and as I said in the beginning, that the cloud was actually a combination of all of these ideas. Another security controls is related to identification, authentication, authorization. One of the things that a customer maybe wants to consider is if they have multiple services in multiple cloud and they want their employees to access these multiple clouds using single sign-on, right? So we talked about federations before, and this allows the identity systems to provide access to multiple domains, right? With one access. Maybe multi-factor authentication is used once, and then allows the employee to access all of these resources from different domains, different cloud providers using one mechanism. Least privilege is always considered. You don't need to give employees more than what they need to do their job. So, and then later there's the audit mechanism, which, if you think about it, is the fourth aspect of access control. So the accountability comes from auditing. Auditing ensures compliance with policies and regulations. So auditing goes and looks at, among other things, looks at logs, looks at if the policies are implemented properly, identify any violations and try to fix them. So there are auditing tools that go and look at all of this information. And log collections play a really important aspect, and log access for employees, for also ultimate users as well. You can see what they're doing. So that's important. Log access sometimes is limited if you are using the PaaS or the SaaS, because you don't have a lot of control over, maybe the platform as a service you have a little bit of control, but you have to use the tools that are provided to you by the cloud service provider. In infrastructure as a service, you can pretty much do anything you want, right? Considering, of course, cost and performance limitations. Okay, now we're moving from the infrastructure to the application security. Cloud, usually, at the end, we want to run applications. That's what we are using them for, right? So we are using the applications whether to directly to use the organization use the applications for its own benefits, like for example accounting systems or employment management or customer management or sales or any of these, right? So all of these are applications that the organization need to use. But also sometimes the organization develop applications to be used by its own customers, to sell products or to sell platform as a service themselves, right? So applications mean a wide range of things here. Applications needs to be protected because if you go back to the early lecture, the first lecture, in fact, we see a lot of vulnerabilities that comes from the applications. Applications is the gateway to the data. Sometimes the attacker try to bypass all the applications and go directly to the databases, but there are also another way to access the sensitive information by hacking the application themselves. So applications need to be secure. Applications can be accessed using a GUI if they are, of course, the cloud means that you can access them through the internet. So the internet provides GUI interface so the user can go and access this applications, or sometimes there are APIs, application programmable interfaces, that's supplied to users so that they can use them to access services. So all of this needs to be looked at, and we need to look at the vulnerabilities. We need to look at mitigation techniques. So what are the known vulnerabilities? So there are two organizations here. One is called Cloud Security Alliance, and the other one called Open Web Application Security Project. The two of them list certain threats or the top threats to cloud computing. So the CSA lists the 4 top threats: data breaches, misconfiguration, inadequate change control, lack of cloud security architecture and strategy, insufficient identity, credential access, and key management, right? And if you look at these four, you see some things that we talked about. I mentioned before that identity management system is crucial for securing the cloud, and seems to be this is one of the things that top threats to cloud computing. Design is another thing that we talked about, and it seems like one of the major threats to cloud computing is probably lack of proper security architecture in designing the applications. Misconfiguration is another thing. So the Open Web Application Security Project lists top 10 threats. Injection flows, we talked about SQL injection before. There are other types as well, including OS injection, where you are entering a sequence of commands one after another, and one of them is malicious. Broken authentication, sensitive data exposure, XML, external entities. So these are among the top 10 threats. So to secure the application, we need to look at the application development life cycle. Same thing when we talked about data security, we talked about the life cycle of the data. So the SDLS stands for secure software. The SDLC talks about software development lifecycle. Right? If we add another S, that becomes secure software development lifecycle, which is SSDLC. And we need to, the organizations who develop applications need to follow this SSDLC lifecycle. There is an organization called SafeCode, which promotes scalable and effective software security programs. They develop or they identify 3 key parts of establishing secure culture. So if you want to, like networks, you have to design them with the security in mind from the beginning. Applications also needs to be developed with security in mind from the beginning, rather than develop the application and then try to fix the problems later. So the 3 key parts that this organization identify. First, you need to have executive support. This may not look important, but actually executive wants profits, wants money, right? And usually the profit or the competition sometimes overrides the security concern. Maybe the executives or the sales wants more sales, and they pressure the developers to develop applications that are not secure just to meet deadlines. So in order to have a secure culture, you have to make sure that the executives understand the security, understand the importance of security. Sometimes this happens the only way this happens by regulations. If the executives fear regulations, then they will be interested in following good security practices. If there are no punishment, if there are no regulations, they probably won't care. That's just an opinion, but yeah, when you look at the patterns of security breaches, at the end you will see that there was a problem with management who are pushing people to meet deadlines, and one of the things that are sacrificed is security. Another key part is program design and implementation, and then finally program sustainment and measurement. Right. So as I said, the software development lifecycle is a process or a series of steps for proper software development. And when you look at the components of this, you see that it starts by collecting requirements and end by the actual operation and management. So let's take a look at each one of these. So any design starts by collecting requirements from users. So in this case, we're going to focus on the security. So you need to look at the security requirements of the ultimate users of this product, of the app, for example. So the security requirements are gathered alongside the business requirements. And these can be, well, the business requirements probably come from either the end users. There is a market research that says the application should be doing this and this and that, or it could be coming from the organization itself where, well, here we want to launch a new product and this is what the product should look like. Security requirements should be collected as well. Then the next step will be the actual design of the application, and in this case, the security requirements has to be part of the design itself. And then there's the actual coding, and in this step, the security measures needs to be tested following the coding, right? So like any other function, you need to write the code and then you need to test to make sure that the code is actually doing what you want it to do. So the part of the testing phase is testing the security and trying to see where is the vulnerabilities are and prevent them or go back and change the coding. Deployment, that's where the product is actually the application in this case will go into the production, and this phase involves the release of the software and includes maybe the configuration part. The configuration setting has to align with the security requirement. You need to secure the APIs. If the application includes API, you need to use identity and access management to secure the application or the API. So, for example, you need to use tokens if the tokens are appropriate, or you need to use open authorization if that's appropriate. So you need to use certain mechanisms to make sure that access to the application or to the API is secure and authenticated. And the last phase is the operations and maintenance, where that actually after the application is being in production, you need to keep track, you need to monitor it. You need to monitor it just so that you can see if there's any anomaly in the behavior of the application, which may indicate an attack. Okay, so we're going to talk about cloud development basics. So I mentioned the word API multiple times. So that's the application programmable interfaces. And APIs, use them all the time, but there are actually two common API types. One is called REST, which is representational state transfer, and the other one is called SOAP, or Simple Object Access Control. REST uses HTTP or HTTPS sometimes, and they can use either JSON or XML data formats in the data part. So let's say, I'll give you an example of application. The application is accessing a database by going and using a URL. The URL will allow you to retrieve information from a database or put information in the database. So to put the data in the database, you have to include a record of an employee, for example, in a JSON format or XML. Either one of these formats is used by the REST. Um, so you need, this is where it becomes, this is where security becomes important, because you want to secure this part. You want to make sure that the data is inserted in database, or the data extracted from the database is being extracted or inserted by legitimate user and using correct format and all of that. So that's why we are mentioning the APIs here. SOAP is like REST, less famous, but also uses XML only, doesn't use JSON. And it can also use, not REST uses HTTP, but SOAP can use other protocols to transfer information. Okay, so what are the vulnerabilities here that comes from these APIs? First of all, injection, where the hackers attempt to execute unauthorized code through input fields. So I may try to insert a record where one of the fields is illegal and it includes some illegal information. So instead of putting a name or a text, I put a code. Right. So this means that in the API or in the application developing in general, we have to make sure that the data is valid and sanitized. Sanitized means that it doesn't include any special characters, any code that may be used to expose information, right? So if I'm getting a username, I have to make sure that the username is actually username with pure characters and so on. Another vulnerability is broken authentication. So we can, if there's inadequate security of authentication or session tokens, can lead to identity compromise. One of the techniques that we can use to access any API is sometimes security tokens, which look like random numbers generated so that a user is identified. If this part is not properly secure, or if we're using another mechanism for authentication that's not properly secure, the hacker may use these to gain access, unauthorized access in this case, right? So we need to make sure that the tokens are legitimate. And if I give you an example, GitHub, for example, make sure that you generate token and the token has a certain expiry date, so it's not there for forever and ever. And one of the reasons is to prevent any misuse of the tokens. Sensitive data exposure. Web applications handling sensitive information must enforce encryption. A security standard should be validated against supported browser versions and protocols. So we need to make sure that data is not improperly exposed by following strong encryption standards, and also making sure that we have the proper keys as well. Speaking of XML, one of the vulnerabilities that come from XML is something called XML external entities. XML looks like this, where you have, let's say, a tag, let's say name, this is the tag, and then you have first so multiple tags, and then last. So that's what XML look like. Okay, so if let's say in another example, maybe um, address. One of the vulnerabilities is, instead of having an address here, the hacker may use a URL that will lead any software that reads this record here into executing the URL. Right, so this is what we are calling external entities. So external entity is a reference to an external resource, such as a file or a URL. If the parser, if the XML reader wants to read the records, normally they will read the record. So we have a record of name, and we have the first name, last name, address, which shouldn't be part of a name, but anyway, as an example, maybe we should change this into a record instead of here, just for the sake of correctness. Maybe we'll call it employee. So the employee record will have a first name, last name, and address. So instead of putting an actual address, the hacker may use a URL. So when the application tries to read the record, it will execute whatever, or it will go to the URL, and that URL may have actually a mechanism to expose the data, right? Or disclose some other information. Maybe the record itself will be exposed to some other entity. So that's what we call as XML external entities, or XSE. And if you are using APIs, you need to secure against that. Any broken access control mechanisms will be vulnerable as well, or will pose a vulnerability. Let's say passwords being leaked, right? So now you have usernames and you have passwords, and you can hackers can access. This is an example of broken access control mechanism. This is by the way, these are the common software vulnerabilities. If we're gonna look at the cloud-specific vulnerabilities, we have a long list here. I'll go over it very quickly, just by, let's say, data breaches. So we have a problem with multi-tenancy. We have a lot of users sharing the same physical environment. It is possible for someone to jump from one virtual machine or one hosted application to another because they are all using the same environment, right? And that can be caused by hacking into the hypervisor. Insufficient identity, credential and access management. I'll skip some of these because we repeated them before. Insecure interfaces, we talked about this in the previous slide. Bugs in general that's either caused by unpatched operating system or some existing vulnerabilities in the virtual environment that can be exploited by hackers. Account hijacking, somebody just go into obtain the credentials of another user and use it to hijack the account. So now the account is taken from the actual user and now it's under control of somebody else. Malicious insiders, people who are actually supposed to be trusted and instead they use their privileges. Advanced persistent threats, these are long-term malware that's introduced to the environment and collects information. Data lost, we talked about that. And also sometimes deletion. Insufficient due diligence. Sometimes the security personnel are not they're not doing their job properly because maybe they are lacking of training, or maybe the policies are not written well. Abuse, always possibility that somebody is actually abusing their privileges. Denial of service, and also sometimes share technology issues, because we are, or as a cloud service, cloud customer, we are sharing users, sharing resources with others, whether we see it or not. But we're sharing resources with others, so this could be um, uh, one part of the vulnerabilities, right? So for software, we have something called threat modeling, which is used to assess the risks. We talked about risk assessment before, and we talked about risk assessment using quantitative versus qualitative um, mechanisms. Right. So threat modeling is done to determine and address any potential threats that face it. There are two prominent models recommended by the organizations that we talked about. Um, so there are actually something called STRIDE and DREAD. The STRIDE is a threat classification scheme, and we're going to look at it. The STRIDE refers to, it's the first letters of 6 categories of classifications. The DREAD is more of a quantitative approach in assessing risks and assign value between 0 and 10 for each category. And the DREAD number, or the risk level, is actually determined by the average of these 5 factors: damage, reproductibility, or reproducibility, sorry, exploitability, affected users, and discoverability. So each one of them will go up to 10, and then when you divide by 5, you get the average, which is from 0 to 10. All right, so the STRIDE model, look at 6 different threats. The first is spoof, or spoofing identity. Spoofing violates authentication. And we know from previous lecture that the definition is pretending to be someone else, right? Or something else. T is for tampering with data, and usually that threatens the integrity, so somebody is moving, changing the data, or modifying it without authorization. Reputation is claiming to be someone that you are not. So it threats the non-repudiation. And somebody says, well, I didn't do it. I change something and say I didn't do it. So that's non-repudiation or repudiation. Information disclosure, that's threats or threatens the confidentiality, and denial of service threatens the availability, and elevation of privilege threatens authorization. Right? So each one of these are threats to the application. So what happens is the application being assessed and say, okay, what are the risks of spoofing? And you give a classification to that. What are the possibility of tampering of data? What are the possibilities or the risks of repudiation, and so on? So any application is assessed based on this model, and now we know what the risks are. Okay? Another model is called DREAD model, and the DREAD also comes from damage, reproducibility, exploitability, affected users, discoverability. So what does that mean? The damage potential measures the potential damage to the system or data if a successful exploit occurs. And then you have a range from 0, which is no damage, to 10, which is total data or system loss. So somebody comes and assess the application and say, okay, from the prospect of damage, we have a risk 5, right? So what is the possibility that anybody will will be able to reproduce the exploit. Let's say there is an exploit in we discover a vulnerability in the application. But that vulnerability can be exploited only by very sophisticated user with a lot of tools and good knowledge. So I may say, well, nearly impossible to reproduce. Yes, we know, but the possibility that somebody can do it is actually very, very small. So maybe we'll give it 0 or 1, where 0 is very or nearly impossible to reproduce. Or maybe some other exploit can be done by anybody. It's very easy, so we'll give it 10. So that's the reproducing of a known exploit. Exploitability measures the skill level or resources required to exploit a threat. So again, somebody needs a lot of resources to be able to hack into the system. So okay, versus somebody doesn't need any tools or very easy to. So that's another measure. How many affected users? This, from the risk perspective, we have the impact, right? So to measure the risk, we need to know the impact, and the impact. And this is the affected users part, where indicates the percentage of user base that can be affected by the exploit. So 0 means no users affected, 10 means all users affected, and it could be somewhere in between. Discoverability measures how easy or difficult it is to discover the threat. So from the security personnel perspective, if somebody, how easy for me to discover if there was a hack, right, or hacking. So 0 means very difficult or impossible, 10 immediately noticeable. So if you use develop an application, you may use one of these models to figure out the level of risks involved with this application. What are the possible application architectures? We have, first of all, you can create an application by starting a virtual machine and building everything from the ground up, right? Nowadays, there are other possibilities as well. One of them is microservice architectures, where the application itself is broken down into multiple services. They are loosely related to each other, and each one of them is focused on single business function. And sometimes one of these things come into becoming, let's say, a hype, or a trend, I should say, a trend where, okay, there are a lot of benefits for microservices, so the developers start talking about microservices and how they are good. And so in theory, each microservice can use different language, so we can use, for each service, we can use different language that suited for that service. We can deploy it using containers, and the containers are managed by something like orchestration tool like Kubernetes. And it makes it easy for the developers to upgrade certain parts of the application while maintaining others. And okay, this is one of the architectures. There's also something called cloud native architectures, where the applications themselves are designed with the cloud in mind. So they're not just being developed and then hosted in the cloud. No, they're using the cloud facilities from the ground up. So they are mainly designed for the cloud. So the whole life cycle and the whole architecture based on the fact that they are being deployed in the cloud. We also have something called serverless architecture, which is, again, rather than having a virtual machine with an application, we going further into the scalability and on-demand concept. It's not just I create. Um, think about every function is on-demand function. If I want to execute a function inside a program, that function will start a process and it will be executed, and then when the function ends, that that function or that service disappears. Right, so it's very granular way to launch applications. um, and then we have something called cloud-based architecture. So you see similarities here. Serverless could be somehow related to microservices. Cloud-based architecture is not necessarily designed to use the cloud, but is designed so that it can be accessed from the internet. So every time you are actually creating an application that has a web interface, you are doing a cloud-based architecture somehow, and not necessarily uses all of the facilities of the cloud, but it allows users to access the application using a web server, a web interface. When you think about the components of the cloud applications, we have seen some of these before: cryptography, sandboxing, um, um, firewalls. Some of these that we have discussed them before. Web application firewall is it protects the application HTTP, HTTPS applications from common attacks like SQL or cross-site scripting. So they are firewalls that they are put in front of the application, and they monitor the traffic. And if they see signs of SQL injections or cross-site scripting, they prevent that from happening. This can be done by firewalls. That can be done by proxies as well. Um, Database activity monitoring is another mechanism where it looks or monitors the activities database read, write, and offers real-time analysis, and then detects any anomalies. So think of it as an IDS designed for a database. XML firewalls, they are from the name, they look for XML um, applications, XML traffic, and look at any attempts of doing SQL injections or XSS or XSSE that we talked about, external um, XEE, which we talked about earlier. API gateway, it looks at the API, and some of these are form of either proxy or a firewall. So it manages traffic to the back-end application, providing rate limiting, access logging. One of the things that maybe a sign of abuse is that a user or a hacker in this case will use the API to access a server beyond the server capacity. So what mechanism we can do to prevent that is by saying, okay, each user will have maybe 10 access per minute, and that's it. Beyond that, well, you have to wait, right? You can see sometimes, especially if you have an example of an API that you are using, there are a limit of how many access per minute that you can do. We talked about cryptography and sandboxing before, so that's should be known. Application virtualization orchestration. So this is the tools that you use to um, create microservices or virtual machines, turn them up or spawn them or turn them, shut them down. So these are needs secure configuration, right? And needs secure management as well, because they may be used as a gateway to hack into the cloud or the applications. Okay, so I mentioned before that identity and access management systems are crucial for all aspects. I think we have seen them in every aspect of the cloud security so far. So let's take a look again briefly on to these systems and see what they are and what we can do with them. So one aspect of the identity management systems is the authentication protocols. So we know about open authorization. We know about LDAP, which is a database. Um, the security assertion markup language is something that probably not discussed before, and it's an XML-based authentication service that we can use to provide authentication between the identity providers and service providers. The lightweight directory access protocol designed for directory services and usually connected with Active Directory or Radius or TechX or one of those centralized access. Federated identity, it comes this related to authentication and single sign-on. So allows a single ID to access multiple systems, even if they are in different domains or across multiple organizations. So that's good, but also it has the potential of if there is a compromise, the hacker may be able to access all systems, right? We talked about identity providers here. So who are the identity providers? The identity providers can be cloud service providers or any third-party provider. So if you want to provide authentications to your applications in the cloud, you could use the cloud service provider tools to provide authentication. Or you can go to another company altogether and use their service. In this case, this is a form of identity as a service, right? So some organizations will give you the identity management systems as a service, so you don't have to have your own hardware or your own tools. We know what the single sign-on is, so it allows users to access all authorized systems under single authentication. Multi-factor authentications we talked about as well. We have Cloud Access Security Broker, which is, we talked about broker at the beginning, sits between a cloud application or server and the customer, monitoring activity, enforcing security policies, and mitigating security events. This could be also a service provided. We have, every time we see agent versus agentless. So agent-based means that we need to install something on a user device that allows this monitoring, right? So if you accessing an application using your phone, so you need to install something on your phone that allows the Cloud Access Security Broker to monitor the traffic and make sure there's no malicious activities, that's why it's being used for companies that employ or deploy bring your own device policies here. So employees will bring their laptops, will bring their phones, and to access the applications provided to them by the employer, they have to use these software. They put it in their hardware to be able to access the resources. The problem with that is it needs an installation. We have a lot of operating systems out there, a lot of brands out there. Some of them may not be compatible. So you have a limitation. Agentless utilizes APIs to inspect all traffic, and it doesn't need any software installed in your device. So you can just access a web or use API, and that will be the way you access the services, and it will monitor your activities and prevent or monitor, enforce any security policies that the company has. All right, so now we're going to talk about security operations. So we talked about protecting the data, we're talking about protecting the infrastructure and protecting the applications. As a security professional, you may be exposed to any of these three as either the customer or the service provider. Now, the operations as well, we need to take a look at them. I'll explain what the operation means. So now we're talking about managing the infrastructure itself, right? And the focus will be mainly on the service provider here. So you want to access the hardware, you want to access the servers, you want to access the switches, routers, whatever. So how do you access them? Most of the time you want to have remote administration. So remote administration should happen using SSH, remote desktop, or VNC. Each one of these needs to be secure and protected. Of course, Secure Shell is an encryption protocol, VPN protocol, so has its own security. But any other access needs to be secure and encrypted. Secure administration for cloud consoles. So you want to access consoles. You need multi-factor authentication, preferably, or at least two-factor authentication. If we are talking about accessing the infrastructure from the customer point of view, right? The customer wants to access VMs that are hosted. So in this case, making sure that the right employees access these resources that's the responsibility of the organization, making sure that only authorized employees can access these resources. Just a little bit of detail here. Employees of an organization are two types, right? Either people who are just consumer of the applications, they just use the applications, and those people who are maintaining the applications. So we're talking here about allowing the cloud console. The cloud console is where you go and provision your VMs, provision your containers, add storage, remove storage. So all of this needs to be managed by the customer through a cloud console. So that has to be secured, and the organization is responsible for making sure that only authorized people can do that. Back to the actual physical connections. KVM, which stands for keyboard, video, and mouse, is a old technique. So you have the switch that rather than having one keyboard, one monitor, one mouse for every server that you have, you may have tens of servers. So instead, you have one switch. You connect the VGA port to that switch, and you connect all the keyboard connections to that switch, and then you have only one keyboard, one mouse, one monitor, and you can just switch between different servers. So you have one terminal that connects to all the servers. So that's KVM switches. There is also another term for KVM which talks about hypervisor. This is not what I mean by that. We talk about the hardware switches. So these KVMs, turns out that they have some vulnerabilities, right? So what is the vulnerability? So if you are looking at one machine, one server, you're typing commands using the keyboard and also receiving um, display. So you're seeing screen on the you're seeing output on a monitor, display on a monitor, and then you switch to another server. Some of these devices will have a buffer. All the keystrokes will have a buffer, or all the keystrokes will go to a buffer in the machine. So when you switch to another machine, another server, some of this information get transferred from the buffer to the machine, or vice versa from the machine to the buffer, and that poses a security risk. And that has been exploited before. So what you need to do here from a security perspective is that you need to secure the KVM so that prevent any physical tampering. Nobody will tamper into these physical devices so that they can eavesdrop on keystrokes or display. You have a limited buffer, so you cannot transfer a lot of data between servers. And also, because they are accessed all the time, somebody may actually change the firmware. So change the firmware on these switches so that you introduce a vulnerability and you will be able to monitor traffic. So the firmware has to be signed, usually digital signatures, and it has to be updated only from the original manufacturer. When you think about the network configuration, right, so you need to apply whatever we talked about before, VLANs, VXLANs, to segment the network, separate different type of traffic, management traffic, storage traffic, administration, whatever, all of these traffic, it has to be separated. DHCP, you can use DHCP to assign IP addresses, but you can also, instead of pure dynamic DHCP or IP address assignment, you can have static IP assignments. What that means that the same server will always go and get the DHCP IP address from a DHCP server, but will always get the same IP address. Right? So there is a static mapping between the MAC address of the server and the IP address. So we need to make sure that DHCP server always assign the same IP address. This is good for management because we know we need the servers to have static IP addresses, but we also don't want to go manually and configure that on them all the time. So we can rely on static IP assignments from DHCP servers. We need to secure the domain name systems. So DNS can be subject to DNS poisoning or DNS spoofing. So in order to prevent that, we can use DNS with security extensions, which require digital signatures to validate DNS lookups, prevent redirections, and all of that. We can use VPNs all the time in the network. We can use software-defined perimeters. This is one of the applications of SDNs to make sure that we are controlling the flows inside the network precisely. Another part of the operation is hardening the system, the operating systems. So hardening in general means securing the machine or configuring the machine to a secure state. So what do we need to do? Remove any default credentials. If there is any default credentials of the system, needs to remove them. Disabling any unnecessary accounts. If we need to install security tools like firewalls, we install them. Host IDS, we install it. Removing any unneeded applications. So we take an operating system which is general, like Linux, and we remove everything that may cause vulnerability, and we leave only the things that know that they are secure. So we have a secure operating system. Right? Um, Before virtualization, this can be done manually by the staff, but now with virtual machines, when you go to the cloud, you may actually get a virtual machine that was cleaned up by the service provider, so you can use something that um, secure already. So you go and you want to use Ubuntu Linux, you get a secure version of Ubuntu Linux or a template. So virtualization introduced machine image, which are templates for creating virtual machines. So you can get an operating system, remove what you need to remove, install what you need to install, and then create an image. Every time you want to create a virtual machine, you use that image, which is personal to you, right? And it's configured based on your standards, your security standards. Sometimes there's something called baseline configuration. So to do all of this, the hardening, you may need skills, and you may need or you may need knowledge that you don't necessarily have. So you may go and use some of the uh, pre-made configurations for you. So to streamline hardening, organization may use baseline configurations. These are documented standard uh, of an information system with specific security settings. So if you need this, you apply these configurations. So there are methods for creating these baselines. You can have images that you can create, like the top here with the machine images. You can create your own image and then use it as a template over and over. So you create your own secure image. Or you can have something called CSP, or Cloud Service Provider Defined Image, where there's pre-configured images for you to use. Sometimes some companies provide baselines. So Microsoft VPN provide configuration guidelines and recommended security settings. So they tell you enable this, disable that, so you can do it for you or do it yourself. And there are also the National Institute of Standards and Technology maintains free configuration checklist for various operating systems and applications. So if you don't really know anything, you can go and look at the NIST, and they have recommendations for every operating system. So if you want a secure operating system, you go to their checklist and follow it, so you get an image. So there are lots of ways to secure the operating system. When it comes to managing the cloud infrastructure, we talked about access controls for remote access. Nothing here new. Use encryption and implement multi-factor authentication. Use the OS baseline compliance monitoring and remediation, patch management. All of these, something that we mentioned before. Just an explanation of or more details here, or summarization in some cases. So you need to identify and remediate non-compliant hosts. If you have lots of virtual machines, you may need to go and make sure that they are scanned, and anything that's not following one of these standards here, you identify it and you fix it. Patch management. Operating systems are upgraded all the time, vulnerabilities discovered, and every time there is a discovery, of a vulnerability, you need to go and update, fix the bugs, update the virtual image. So this is an ongoing process, right? And when we're talking about cloud operations, you need to do this all the time. You cannot do security without continuous monitoring, so you need to monitor the performance for two reasons. One, make sure that there are no anomalies. The other is to make sure that your resources are actually meet whatever service level agreements and contract you gave to the customers, right? So you're going to monitor the CPU, you monitor disk usage, you monitor memory usage, network usage, and so on. Hardware monitoring, some of these servers will have their own interface for their own hardware monitoring. You can monitor all aspects, CPU, temperature, fan, power supply, all of this. So if you are running the cloud infrastructure, you need to monitor all of this. You need to also make sure doing backup by itself is not going to secure anything, or is not going to be. A lot of organizations would just be happy to do the backup without actually checking if the backup is correct, right? So every once in a while you need to do backup, and also you need to test if you can restore this information. And the backup is one of the vulnerable parts of the data lifecycle. Why? Because the hackers may not attack the database directly, they may just go and attack the backup of the database, because the assumption is that probably not very secure. Right? So you have to, part of the network operations is to make sure that the backup and restore functions are secure and the backup is secure. Network security controls, that's the common in all networks. You need to use firewalls. You need, whether it's an actual hardware and appliance, or virtual networks, or sometimes host-based networks as well. If you are running a virtual environment, virtual network, as a customer, then you probably need to use firewalls to protect or to separate different zones, different trust zones. And these, of course, they're not going to be hardware, they're going to be virtual machines. Network security controls. Again, this is probably going more into the details of this. So firewalls, we talked about firewalls before. We have the host-based, we have the network generation firewalls, which can combine multiple functions. We talked about IDS, IPS. We also, we didn't really talk much about honeypots and honeynuts. These are, from the name, these are tools that can be used to attract hackers or malicious software into traps. So we can discover them by giving them something. It looks like a vulnerabilities, and the malicious software will say, oh, okay, great, there is some vulnerable software there, so let's go and attack it, and then we capture it, or we know about it when we look at it. The only problem here is that there are some legal concerns about that. Which called entrapment, right? So entrapment means that, let's say I put $1,000 in front of my house and monitor the $1,000 using a security camera, and when somebody comes and picked up the money, I'll call the police and arrest them because they are now stealing. Well, that's called entrapment, and sometimes this is illegal. Right? You cannot lure people into doing something criminal and then arrest them. In some cases, because there are certain, when we talked about regulations in a previous lecture, there are severe penalties for hacking in the criminal code. So if you are doing honeypots and honeynets, you have to be careful about not, not doing something illegal here. There are also vulnerability assessments that you can do to secure the network. Vulnerability assessments aim to detect vulnerabilities before attackers find them. And there are also the penetration testing, which are proactive ways to find or test the system for, let's say, I do all of these controls and secure my application, secure my network, secure my cloud environment, all of this. How does I know for sure that then all of this is secure? So you have to do some tests. Those tests aim at trying to infiltrate the network. So that's what we talk about, or what we mean by penetration testing. Penetration testing also has to follow certain rules because there are certain legal issues around it. So that's what we mean by the choice of the assessment depends on the regulations and compliance requirements. Management planes. For the network, we have network management, and network management deals with managing the devices, changing the configuration, collecting performance metrics, all of that. And it requires logging, access control, monitoring, and so on. So we need to, on one hand, management controls need to access a lot of information, access a lot of devices. So they are, if being misused or being infiltrated by a hacker, they can be used to create a lot of damage. So we have to make sure that the management plane is isolated from everything else, as we mentioned before. So management planes is isolated from all the other functions. And also, it should not provide control over the entire infrastructure. So maybe I need to divide my network or my resources into segments. So if one part is hacked, it's not like a loss of everything. Now we'll talk about different subject, which is the operational control and standards. So we have the concept of change management. So in general, organizations should not make any change, like upgrading an application, removing a server and upgrading another server, introducing a new rack to the data center, or moving the data center. Any change should go through a change management process. And change management process, it depends on the organization. It could be, if a small organization, could be a small process, flexible and easy, or it could be very complicated process. It depends. And I imagine that if a cloud service provider with millions of customers and they want to make a change, they have to go through a rigorous change management process. The change management process main goal is to make sure that everything happens with the least impact, with the least risk, and in compliance with any regulations and policies there. And this is a topic that we will leave to another course, but involves steps like change proposal, request for change, approval, scheduling, deployment, and so on, post-implementation, and all of this. So there is a rigorous change management process there. And there is also something called continuity management. So before I go any further, so if you are a cloud service provider, you probably have to have a change management process. Actually, any organization may need to have a change management process in place for making any change. Continuity management is concerned mostly about how the service will be restored after some kind of a disaster, environmental disaster, or financial disaster, or hacking, security breach. So how can we go back to restoring the service? So organizations usually put documentation in place that tells um, what what happened after the disaster, what happens to restore information, restore processes, restore products, restore services, so that we can go back to normal. Information security management, so that ensures data, IT services, systems, confidentiality, integrity, and availability. So these are the three pillars. These are the three pillars of the security. So that they need to be these controls need to be in place. And I guess by the time you get to this point, you already know what you need to do in information security management. And then we have continual service improvement management, which um, now you put all of these in place, but you need to make sure that um, they are actually being implemented and being implemented correctly and according to the policies that you put. So you need to collect metric. It depends on the organization. You may need to collect information from the users. You need to collect information about financial. So is the security measures that you put there worth the money that you spent on? Maybe you need to make changes. Maybe you need to do another risk assessments and so on. So these are all definitions. And incident management addresses disruptive events, aiming to limit impact and restore normal operations. So you may hear this term used when something happened. In this case, a breach, security breach. What will happen? So sometimes you need to save evidence for prosecution later. You need to prevent any further breach. So you need to put controls in place to prevent any further breach. You need to look at uh, how wide the breach was, who are affected, and all of this goes into a certain steps. We're not talking about these steps in details in this case, but this is one of the operation controls and standards. Problem management identifies and mitigates potential issues to prevent problems, collects and analyzes data to predict and prevent recurring issues. Um, for products and applications, you need to have something called release and deployment management, where um, you need to plan, coordinate, and execute and validate changes and rollouts to the production environment. This is similar to the change management, right? So it's have similarities. It just mostly concerned about deployment of maybe applications or services, while change management is generic for everything, right? Configuration management, this is applies to networking, applies to servers. So this is what includes or includes what backing up configuration, tracking information about, like, for example, keeping inventory of the servers that you have, the switches that you have, the virtual systems that you have. So tracking all of this, tracking assets, and making sure that from the security perspective that all of these are compliant with any security processes that you have. Service level management, SLAs, for example, deals with performance levels that you are committing to customers, and again, making sure that the contract, you have compliance with the contract obligations. Same thing here with the availability management. You need to look at the requirements from the SLAs and about the percentage of availability, the reliability, and capacity. Same, you can look at these last three points here and see they are all specified in service level agreement. Each one of them talks about, for example, bandwidth, that's capacity management. Reliability is concerned about the uptime. And then you talk about certain performance levels, right? For example, if you are talking to a cloud service provider about complaint, like you issue complaint or you issue service ticket. So how fast is the service ticket attended to and responded to, right? So all of these are part of the operations. So this brings us to the end of this lecture. Thank you for listening, and this is the last lecture in this course. Any other lecture will be added later, but this will be the conclusion of this course for now. Thank you very much for listening to all of these recordings. I hope you find them useful, and talk to you in another course.